Right now, somewhere in the world, a fighter jet is breaking the sound barrier at twice the speed of sound, carrying weapons that could level city blocks. These aren't just machines, they're the apex predators of the sky, engineered to dominate airspace and project power across continents. From Cold War legends that terrorized enemies to modern stealth fighters that appear invisible to radar, today we're counting down the 10 most legendary fighter jets that didn't just change warfare. They rewrote the rules of what's possible in the sky. McDonnell Douglas F-4 Phantom II. The F-4 Phantom II holds a record that no other American fighter will ever match. 5,195 aircraft built, making it the most produced supersonic military aircraft in U.S. history. This twin-engine beast could carry over 18,000 pounds of weapons while screaming through the sky at Mach 2.2, but what made it truly legendary wasn't just its raw power. During the Vietnam War, the Phantom proved that brute force could overcome elegant design. It was big, it was ugly, and it smoked like a freight train, earning the nickname Double Ugly. But when North Vietnamese MiG-21S tried to challenge American air superiority, the F-4 responded with devastating effectiveness. All 5 American servicemen who became aces during Vietnam did so flying Phantoms. The aircraft's versatility was unmatched for its era. It could intercept Soviet bombers at high altitude, deliver nuclear weapons deep into enemy territory, or provide close air support for ground troops. Its twin-seat configuration allowed for a pilot and weapons systems officer, creating a deadly team that could manage complex missions while maintaining situational awareness. What truly set the Phantom apart was its adaptability. Initially designed without an internal cannon, later variants incorporated the M61 Vulcan rotary cannon when combat experience showed the need for close-range firepower. The F-4 served with 11 countries and remained in frontline service for over 3 decades, proving that sometimes the most successful fighter isn't the prettiest. It's the one that gets the job done. Mikoyan-Gurevich MiG-21. More than 10,000 MiG-21AS have been built since 1955, making it the most produced supersonic fighter in aviation history. This Soviet interceptor, codenamed Fishbed by NATO, became the backbone of air forces in over 60 countries and still flies today, 7 decades after its first flight. The MiG-21's design philosophy was brutally simple: create the smallest, lightest airframe possible around the most powerful engine available. The result was a fighter that could climb at 46,250 feet per minute and reach Mach 2.05, performance that rivaled much larger and more expensive Western fighters. Its delta wing configuration made it incredibly fast in a straight line, though it bled energy quickly in turning fights. In Vietnam, the MiG-21 became the F-4 Phantom's most dangerous adversary. While American pilots had superior training and equipment, the MiG-21's small size and agility made it a formidable opponent in close combat. North Vietnamese pilots shot down approximately 50 American aircraft with MiG-21S, though they lost 68 of their own in return. The aircraft's true genius lay in its simplicity and reliability. Unlike complex Western fighters that required extensive maintenance, the MiG-21 could operate from rough airstrips with minimal ground support. Its Tumansky engine featured an emergency power mode that could boost thrust to over 21,000 pounds for 2 minutes, giving pilots a crucial advantage when they needed it most. This combination of performance, reliability, and affordability made the MiG-21 the AK-47 of fighter jets: simple, effective, and everywhere. McDonnell Douglas FA-18 Hornet. The FA-18 Hornet revolutionized naval aviation by becoming the world's first true multi-role fighter, capable of switching between air-to-air and air-to-ground missions during the same flight. This twin-engine marvel entered service in 1983 and immediately proved that versatility could be just as valuable as raw performance. During Operation Desert Storm, Hornets demonstrated their unique capabilities by shooting down enemy fighters and bombing ground targets within the same mission. This flexibility allowed carrier air wings to adapt to changing tactical situations without requiring different aircraft for different roles. The Hornet's robust design meant it could take direct hits from surface-to-air missiles, return to the carrier, be repaired overnight, and fly again the next day. What made the Hornet truly special was its pilot-friendly design. The aircraft featured advanced fly-by-wire controls that made it nearly impossible to stall or lose control, even in extreme combat maneuvers. Its twin-engine configuration provided redundancy crucial for carrier operations, where a single engine failure over the ocean could be fatal. The Hornet's carrier capabilities were equally impressive. It could operate from World War II-era carriers with limited deck space as well as modern supercarriers, making it incredibly versatile for naval operations. Its stable landing approach and excellent low-speed handling characteristics made carrier landings safer and more predictable than previous naval fighters. The FA-18 became the workhorse of both Navy and Marine Corps aviation, serving as the primary bridge platform until the F-35's arrival, proving that sometimes the best fighter is the one that can do everything well. General Dynamics F-16 Fighting Falcon. Over 4,600 F-16 Fighting Falcons have been built since 1976, making it honestly one of the most successful fighter aircraft in history. This single-engine lightweight fighter really proved that bigger isn't always better, combining exceptional maneuverability with cutting-edge technology in a package that dozens of countries could actually afford. The F-16's revolutionary design centered around one key innovation: fly-by-wire flight controls. This computer-controlled system allowed the aircraft to be inherently unstable, meaning it actually wanted to tumble out of control. While that sounds dangerous, it actually made the F-16 incredibly maneuverable, able to change direction faster than any previous fighter. The pilot sits in a reclined position under a bubble canopy that provides 360-degree visibility, which is just crucial for spotting threats in air-to-air combat. In combat, the F-16 has proven itself over and over again. Israeli F-16S destroyed Iraq's nuclear reactor in 1981, flying a precision strike mission that required perfect navigation and timing. During the Gulf War, F-16S flew more sorties than any other coalition aircraft, really demonstrating their reliability and versatility in both air-to-air and air-to-ground roles. The Fighting Falcon's success comes from its balance of performance, reliability, and cost-effectiveness. It can pull 9 Gs in combat maneuvers, reach Mach 2, and carry a variety of weapons, all while remaining affordable enough for smaller air forces to operate. This combination has made the F-16 the backbone of NATO air power and, honestly, the standard by which all other lightweight fighters are measured. It just goes to show that sometimes the most successful design is the one that gets the fundamentals exactly right. McDonnell Douglas F-15 Eagle. The F-15 Eagle holds the most impressive combat record of any modern fighter: 104 air-to-air victories with 0 losses in aerial combat. This twin-engine air superiority fighter was designed with one mission in mind: to dominate the skies against any opponent, anywhere in the world. When the F-15 first flew in 1972, it represented a quantum leap in fighter technology. Its twin Pratt and Whitney engines produced enough thrust to accelerate the aircraft straight up like a rocket, while its advanced radar could track multiple targets simultaneously at ranges exceeding 100 miles. The combination of raw power and sophisticated sensors made the Eagle nearly invincible in air-to-air combat. The F-15's combat debut came with the Israeli Air Force in 1979, where it quickly established air superiority over Lebanon. During the 1982 Lebanon War, Israeli F-15S shot down 40 Syrian aircraft without losing a single Eagle. This pattern repeated in every conflict where F-15S participated: Gulf War, Bosnia, Iraq. The Eagle consistently dominated enemy fighters. What makes the F-15 truly remarkable is its longevity. Despite being designed in the 1960s, continuous upgrades have kept it relevant against modern threats. The latest F-15EX variant incorporates advanced radar, digital fly-by-wire controls, and can carry up to 22 air-to-air missiles, more than any other fighter in production. The Eagle's success formula is simple: overwhelming power, superior sensors, and pilot-friendly design. It really proves that when you build a fighter to be the absolute best at air-to-air combat, that superiority can last for decades. Sukhoi Su-27 Flanker. The Su-27 Flanker was the Soviet Union's answer to the F-15 Eagle, and in many ways it actually exceeded its American rival's capabilities. This massive twin-engine fighter combined incredible range, heavy armament, and super maneuverability in a package that could patrol the vast expanses of Soviet airspace. At 72 feet long with a 48-foot wingspan, the Su-27 is one of the largest fighters ever built, but its size really serves a purpose. Internal fuel capacity of over 20,000 pounds gives it a combat radius exceeding 1,000 miles. allowing it to escort bombers deep into enemy territory or patrol remote borders without refueling. Its twin AL-31F engines produce 27,600 pounds of thrust each, giving the massive fighter a thrust-to-weight ratio that enables vertical climbs and incredible acceleration. The flanker's party trick is its super maneuverability. The aircraft can perform the Cobra maneuver where it suddenly pitches its nose up to 90 degrees while maintaining forward momentum, then snaps back to level flight. This extreme maneuver can cause pursuing fighters to overshoot, giving the Su-27 a tactical advantage in close combat. In combat, the Su-27 has proven its worth. During the Eritrean-Ethiopian War, Ethiopian Su-27S shot down 5 Eritrean MiG-29S, demonstrating the flanker's superiority even over other advanced Soviet fighters. The aircraft's sophisticated radar can track 10 targets simultaneously while engaging 4, making it a formidable opponent in beyond visual range combat. The Su-27's influence extends far beyond Russia, spawning variants like the Su-30, Su-33, and Su-35, proving that sometimes the best response to a great fighter is an even greater one. Lockheed Martin F-22 Raptor. So, the F-22 Raptor represents the pinnacle of fighter aircraft technology. It's a fifth-generation stealth fighter that, honestly, combines invisibility, supercruise, and super maneuverability in ways that no other aircraft can really match. Only 187 operational Raptors were built, making it the most exclusive fighter jet in the world. The Raptor's stealth technology makes it, well, virtually invisible to enemy radar. Its angular surfaces and special coatings reduce its radar signature to that of a marble, which allows it to penetrate enemy airspace undetected. But you know, stealth is just one part of the equation. The F-22 can supercruise, meaning it can fly faster than sound without using afterburners, giving it the ability to dash between targets while conserving fuel and maintaining stealth. In air-to-air combat, the F-22 is simply unmatched. Its AN/APG-77 radar can track multiple targets at extreme ranges while, impressively, remaining undetected itself. The aircraft carries 6 AIM-120 AMRAAM missiles internally, allowing it to engage multiple targets simultaneously. Its thrust vectoring engines enable maneuvers that, honestly, defy physics, including the ability to point its nose in directions its body isn't even traveling. The Raptor's combat record, while limited, is perfect. During operations in Syria, F-22S provided air superiority while remaining completely undetected by enemy forces. The aircraft's mere presence in a combat zone forces enemies to alter their tactics, knowing they face an opponent they cannot see or effectively engage. At $150 million per aircraft, the F-22 is the most expensive fighter ever built, but it represents a level of technological superiority that, honestly, may not be matched for decades. Dassault Rafale. The Dassault Rafale proves that sometimes the best fighter comes from going it alone. When France withdrew from the Eurofighter program in the 1980s, they created something uniquely French, an omnirole fighter that could excel in every mission from air superiority to nuclear strike. The Rafale's twin-engine Canard Delta design gives it exceptional agility while maintaining stability across all flight regimes. Its Spectra electronic warfare system provides 360-degree threat detection and countermeasures, while the RBE-2 AESA radar can track 40 targets simultaneously. This sensor fusion creates a level of situational awareness that few fighters can match. In 2009, a Rafale achieved something remarkable. It shot down an F-22 Raptor in a training exercise. While the engagement occurred under specific conditions that favored the Rafale, it demonstrated that even the world's most advanced stealth fighter isn't invincible against a well-flown conventional aircraft with superior sensors and weapons. The Rafale's combat record spans from Afghanistan to Libya to Mali, where it has consistently delivered precision strikes while maintaining air superiority. Its ability to operate from both land bases and aircraft carriers makes it uniquely versatile among modern fighters. The aircraft can carry up to 21,000 pounds of weapons across 14 hardpoints, including the Scalp cruise missile for long-range precision strikes. What sets the Rafale apart is its integration of French technology throughout. From its SNECMA engines to its Thales radar, the Rafale represents complete technological sovereignty, proving that innovation doesn't require international cooperation. Sometimes it requires the courage to go your own way. Eurofighter Typhoon. The Eurofighter Typhoon represents the pinnacle of European aerospace cooperation, combining the expertise of Britain, Germany, Italy, and Spain into a fighter that excels in both air-to-air and air-to-ground missions. This twin-engine Canard Delta fighter proves that international collaboration can produce world-class military technology. The Typhoon's design prioritizes agility above all else. Its Canard Delta configuration and powerful EJ-200 engines give it a thrust-to-weight ratio that enables sustained vertical climbs and turn rates that consistently outperform competitors in training exercises. The aircraft can supercruise at Mach 1.5 without afterburners, giving it the ability to dash between targets while conserving fuel. In combat, the Typhoon has proven its worth over Libya, where it flew both air-to-air patrols and precision ground strikes. Its Captor-E-ISA radar provides exceptional detection capabilities, while the Pirate infrared search and track system allows for passive target detection. The integration of Meteor Beyond Visual Range missiles gives the Typhoon one of the longest engagement ranges of any fighter. What makes the Typhoon unique is its swing roll capability, the ability to switch between air-to-air and air-to-ground missions during the same flight. A Typhoon can begin a mission configured for air superiority, engage enemy fighters, then immediately transition to ground attack mode to strike surface targets, all while maintaining full defensive capabilities. With over 720 aircraft ordered by 9 countries, the Typhoon has become Europe's premier fighter, proving that when nations combine their technological expertise, they can create aircraft that rival anything produced by traditional aerospace superpowers. Grumman F-14 Tomcat. The F-14 Tomcat was the ultimate interceptor, designed to protect U.S. Navy carrier battle groups from Soviet bomber attacks during the Cold War. This twin-engine, variable sweep wing fighter could engage multiple targets at ranges exceeding 100 miles, making it the guardian of the fleet for over 3 decades. The Tomcat's most distinctive feature was its variable sweep wings, which could adjust from 20 to 68 degrees depending on flight conditions. This gave the F-14 exceptional performance across all speed ranges, efficient cruise flight with wings swept forward, and high-speed dash capability with wings swept back. Combined with its powerful twin engines, this made the Tomcat one of the fastest fighters ever built, capable of exceeding Mach 2.3. The F-14's weapons system was revolutionary. Its AWG-9 radar could track 24 targets simultaneously while engaging 6 with AIM-54 Phoenix missiles. These massive missiles had a range of over 100 miles and could destroy targets the size of bombers at extreme distances. No other fighter could match this long-range intercept capability. In combat, the Tomcat proved its worth during the 1980s confrontations with Libya, where F-14s shot down Libyan fighters in several engagements. The aircraft's combination of speed, range, and powerful radar made it nearly invincible in air-to-air combat when flown by skilled crews. The F-14's legacy extends beyond combat effectiveness. Its starring role in Top Gun made it the most recognizable fighter jet in popular culture, inspiring generations of pilots and aviation enthusiasts. When the last Tomcat retired in 2006, it marked the end of an era in naval aviation. From the Phantom's brute force to the Raptor's technological supremacy, these 10 fighters didn't just dominate their eras. They defined what air power means in the modern world. Each aircraft pushed the boundaries of what was possible, whether through raw performance, innovative design, or revolutionary technology. As we look toward the future with 6th-generation fighters on the horizon, these legends remind us that the greatest aircraft aren't just machines. They're the result of human ingenuity, engineering excellence, and the relentless pursuit of air superiority. Thanks for watching Stellar Tech, and don't forget to subscribe for more incredible stories from the world of aviation and technology. Imagine this. After 47 years drifting through the cosmic void, humanity's most distant messenger suddenly detects something that, honestly, shouldn't exist. NASA's Voyager 1, now 15 billion miles from Earth, has captured evidence of 305 mysterious objects moving in perfect formation through interstellar space. These aren't planets, asteroids, or comets, they're something else entirely, gliding through the darkness with purpose and precision that just, well, defies every law of physics we know. What Voyager discovered out there has left scientists questioning everything we thought we understood about the universe. The lonely pioneer's impossible discovery. Deep in the frozen emptiness between stars, a tiny machine no bigger than a small car continues its eternal journey through the cosmic dark. Voyager 1, launched when Star Wars first hit theaters in 1977, has become humanity's most distant ambassador, traveling over 15 billion miles from Earth into the mysterious realm of interstellar space. This ancient spacecraft, powered by decaying plutonium and running on 1970s technology with less computing power than a modern calculator, was never meant to survive this long. Its mission was simple: fly by Jupiter and Saturn, then fade into obscurity. Instead, it crossed into interstellar space in 2012, becoming the first human-made object to venture beyond our sun's protective influence. Communication with Voyager takes 22 hours each way, like having a conversation where every response takes nearly 2 full days. Yet despite these impossible distances and technological limitations, this remarkable machine continues whispering back to us across the stars, carrying its famous golden record message to any intelligence that might find it. But recently, Voyager detected something in the darkness that has changed everything we thought we knew about the space between stars. The first anomaly that changed everything. What started as a routine data transmission from Voyager 1 quickly became something that would shake the foundations of space science. Hidden within the endless stream of plasma readings and magnetic field measurements was a tiny anomaly, a faint reflection of light that seemed insignificant at first glance. Dr. Eliza Karna, one of the mission specialists who first noticed the reading, described it as like shouting into a canyon for decades and finally something shouts back. The signal was so subtle that NASA's Jet Propulsion Laboratory initially dismissed it as background noise, just another particle drifting randomly through the cosmic void. But then the object began to move in ways that caught everyone's attention. It didn't tumble chaotically like space debris or follow the predictable paths of natural objects. Instead, it curved and accelerated with what appeared to be deliberate control, gliding smoothly through space as if guided by intelligence. Systems analyst Carlo Romero observed that the object's movement was unlike anything natural, describing it as the kind of deliberate motion one might expect from a drone rather than a rock. In the physics of space, things don't move with purpose unless something is making them move that way. When natural laws break down. When natural laws break down, when something unusual appears in space, scientists follow a standard protocol. They systematically check every known possibility. Is it a distant moon, a new asteroid, a comet with an unusual orbit? One by one, the team at NASA worked through these familiar explanations, and one by one, each possibility crumbled away. This object defied every category. It wasn't a planet, far too small, not a comet either. There was no tail, no ice trail, no heat signature that would indicate sublimating materials. It didn't glow like a star, and gravitational lensing couldn't explain its behavior. Even space dust was ruled out because dust particles don't suddenly change direction mid-flight. Dr. Lucas Hang at the Jet Propulsion Laboratory ran simulation after simulation, trying to match the object's behavior to known physical models. What makes space objects predictable is physics. Everything moves according to established patterns and forces. But this object broke those rules entirely. Its path bent in ways that didn't match any known orbital mechanics, with no drift or decay that would be expected from natural phenomena. The team was forced to confront an uncomfortable truth. What they were seeing wasn't just unknown, it was unnatural. The twin confirmation that proved everything. Just as scientists were struggling to understand what Voyager 1 had detected, something extraordinary happened that, honestly, transformed speculation into undeniable reality. Voyager 2, traveling a completely different path millions of miles away, detected something eerily similar, the same magnetic fluctuations, the same pulse patterns, matching signal signatures that changed everything. This cross-confirmation was the turning point in the investigation. Two separate spacecraft using independent instruments in different regions of space had detected nearly identical phenomena. This ruled out any possibility of internal error, software glitches, or sensor malfunctions on Voyager 1. ESA analyst Merck Fontaine compared it to, quote, two lighthouses both catching a flash of something passing between them. The dual detection gave the anomaly weight and credibility that just couldn't be dismissed. This wasn't noise or equipment failure, it was a real, coordinated phenomenon happening in the space between stars. With this confirmation, NASA quietly triggered what's known as a Level 3 alert. a designation reserved only for phenomena that don't fit within current scientific understanding. The event was real, the mathematics were consistent, and the movement patterns appeared deliberate. Nobody knew what to make of it, but everyone knew it was significant. The formation that defied physics. When the team analyzed the complete telemetry logs, what they discovered honestly sent chills through the scientific community. This wasn't just one or two anomalies drifting through space. There were 305 objects, all moving together in perfect formation like a cosmic ballet choreographed by an unknown intelligence. Each object glided past Voyager 1 in what appeared to be a coordinated arc, smooth and precise in their movements. These weren't debris fragments scattered randomly through space. There were no heat signatures, no tails, no signs of decay typical of natural objects. Most striking of all, the readings showed rhythmic pulses echoing through the plasma waves, patterns that suggested engineering rather than chance. The 305 objects maintained their relative positions with impossible precision. In space, groups of objects naturally spread out over time due to gravitational influences and velocity differences. Yet these maintained formation like a flock of birds or a school of fish. Except this was happening in the vacuum of space where such coordinated movement shouldn't be possible without technology. The scale was particularly unsettling. A single anomalous object might be explained as instrument error, but 305 objects all displaying the same unnatural characteristics suggested something far more significant was happening in interstellar space. The language hidden in plasma waves. As scientists examined the data more closely, they discovered something that, honestly, challenged the very nature of what they were observing. The plasma wave pulses weren't random cosmic noise. They contained patterns of repetition that were steady, measured, and structured in ways that suggested communication or control systems. Dr. Serena Patel from Caltech observed that the patterns felt less like nature and more like a language or system. The signals had loops, sequences, and structures that hinted at complexity far beyond random electromagnetic interference. These objects weren't just passing by Voyager, they seemed to be broadcasting signals as if pinging, scanning, or communicating with each other. The implications were staggering. If these patterns represented some form of communication, it suggested the objects were part of a coordinated network, operating with shared purpose and intelligence. Some experts went further, with ESA's Eric Lousy suggesting this could be some sort of probe network, though he was quickly asked to stop speculating publicly. To confirm their readings weren't the result of equipment failure, the team activated one of Voyager's oldest backup systems, a telemetry channel unused since the 1990s. It confirmed everything. The signals, the paths, the formations were all real. Impossible propulsion beyond our understanding. The mystery deepened when Voyager's instruments revealed how these objects moved through space. There were no engine flares, no ion trails, no signs of any propulsion system that human science could recognize. Yet, Doppler shift measurements showed these objects accelerating rapidly, smoothly, and directionally through the cosmic void. Some were moving faster than anything humans have ever launched into space. According to the data, certain objects were traveling at speeds that exceeded the calculated escape velocity of the entire Milky Way galaxy. These weren't passive objects drifting through space, they were powered somehow, navigating with purpose and incredible velocity. Dr. Caleb Ramirez from MIT noted that, well, they're not floating through space, they're navigating it. What worried him more was their calculated path. These objects deliberately avoided our solar system, passing by at a safe distance as if they had no interest in stopping or investigating our cosmic neighborhood. The propulsion method remained completely mysterious. Nothing in current technology could explain how these objects moved. They appeared to be manipulating space itself, creating waves or ripples in space-time that allowed them to glide forward without conventional thrust. It was as if they were using the medium of space itself for propulsion. Earth hears the cosmic whispers. While NASA focused on analyzing Voyager's data, something remarkable began happening on Earth. Amateur radio operators across the globe, hobbyists with backyard setups built from spare parts, started reporting strange activity in their equipment. They were detecting weak, irregular pulses that didn't match any known terrestrial source. At first, these reports seemed unrelated to Voyager's discoveries. Radio interference happens constantly, and most dismissed it as coincidence. But when the timestamps were compared, they aligned almost perfectly with the hours when Voyager recorded its most intense plasma anomalies. These weren't professional observatories or official deep space listening stations. Most setups were designed to catch meteor scatter, amateur satellites, or solar flare activity, yet somehow, they were detecting faint echoes of what Voyager had encountered billions of miles away. The signals weren't strong, but they had pattern and regularity, like ripples reflecting off invisible walls in Earth's ionosphere. This raised troubling questions. Was this electromagnetic bleed-through accidental, or was something deliberately testing Earth's listening capabilities? The uncertainty triggered quiet security measures as NASA began encrypting parts of its deep space communications, recognizing that if amateur enthusiasts could detect these fragments, so could others with more sophisticated equipment. The machine that changed itself. Perhaps the most unsettling development was what happened to Voyager 1 itself. After one of the magnetic pulses from the passing objects, the spacecraft began exhibiting behavior that was never programmed into its systems. Its guidance system, the attitude and articulation control system, started rerouting data through old unused pathways that hadn't been active in decades. This wasn't system failure, it was systematic reconfiguration. Voyager was reactivating memory segments untouched since the 1980s, rerouting telemetry in ways that defied its original programming. The spacecraft was still responding to commands and transmitting data, but it was also doing something entirely new. Engineers had to dig through dusty file cabinets at NASA's Jet Propulsion Laboratory, searching for 1970s assembly language code and handwritten notes in paper manuals. Every diagnostic test took 44 hours, 22 hours to send a command, 22 hours to receive a response. Yet despite their efforts to reset the system, the new behaviors persisted. What they discovered was both promising and terrifying. The machine was stable, the instruments were functioning, but Voyager had fundamentally changed. Whatever had caused this transformation, it wasn't internal decay or software corruption. Voyager had encountered something that altered its very nature, making it part of something larger than its original mission. The network beyond the stars. As analysis continued, scientists began to consider a possibility that challenged everything we thought we knew about our place in the universe. The structured signals, the quantum-like oscillations, the coordinated movement patterns, all suggested that Voyager hadn't just witnessed random events in deep space. It had encountered evidence of a vast communication network operating in the interstellar medium. The waveforms resembled quantum entanglement experiments conducted on Earth, the same signals researchers use to transmit information between particles separated by distance. If this interpretation was correct, Voyager had stumbled into a galactic communication system that had been operating for millennia, undetected until now. Voyager's analog design, free from the electromagnetic noise of modern digital systems, made it the perfect cosmic microphone. Its position beyond the solar system's interference allowed it to detect signals that would be impossible to observe from Earth. The spacecraft had become an accidental eavesdropper on conversations not meant for human ears. The implications are staggering. If these 305 objects were part of a larger network, it suggests that the galaxy contains communication infrastructure built by intelligences we've never encountered. Voyager may have crossed into something we haven't mapped, not just empty space, but an active data layer that's been running unnoticed throughout the cosmos. From a single anomaly to 305 coordinated objects moving through interstellar space, Voyager 1's discovery has shattered our understanding of the cosmic void. Whether these objects represent natural phenomena beyond our current physics, or evidence of intelligence operating on a galactic scale, one thing is certain: the universe is far stranger and more active than we ever imagined. As Voyager continues its eternal journey through the darkness, it carries with it the knowledge that we are not alone in the vast emptiness between stars. Thanks for watching Stellar Tech, and don't forget to subscribe for more cosmic revelations. Right now, 15 billion miles from Earth, humanity's most distant messenger is revealing secrets that are, honestly, rewriting our understanding of space. Voyager 1 crossed into interstellar space back in 2012, becoming the first human-made object to leave our solar system's protective bubble. But after a terrifying communication blackout in 2023, the spacecraft came back online with data that absolutely stunned scientists. The space between stars isn't the empty void we imagined. It's actually a dynamic, structured environment filled with cosmic weather, invisible boundaries, and phenomena that challenge everything we thought we knew about our galaxy.
The Silent Crisis.
April 2024 brought relief after months of cosmic terror. Voyager 1 had gone completely silent, transmitting only garbled signals that made no sense to NASA engineers at the Jet Propulsion Laboratory. After 46 years of faithful service, humanity's most distant explorer was dying. The culprit was a corrupted memory chip, likely damaged by a cosmic ray strike. The very phenomenon Voyager was studying had wounded it. Engineers faced an unprecedented challenge, performing brain surgery on a spacecraft using 1970s technology from 15 billion miles away, where radio signals take over 22 hours for a round trip. The rescue operation required rerouting code into backup memory areas, essentially giving CPR to a robot that predated most modern computers. By May 2024, the patient showed signs of life, with all 4 science instruments gradually coming back online. This wasn't just an engineering triumph, it was humanity's lifeline to the only measurements we have from beyond our solar system.
Magnetic mysteries beyond the edge.
The first shock came from Voyager's magnetometer readings after crossing the heliopause. Scientists expected some differences, but the interstellar magnetic field showed a dramatic misalignment compared to our sun's magnetic influence. This wasn't a gradual transition, it was a sharp boundary suggesting something far more significant than anyone had anticipated. The readings point to Voyager 1 entering a magnetic turbulence zone where galactic magnetic fields twist and reconnect in ways that could, honestly, reshape our understanding of galactic structure. These aren't small ripples in space, they're fundamental forces operating on scales larger than our entire solar system. The magnetic field orientations Voyager measures might even channel cosmic material into denser regions, potentially influencing where new stars form in our region of the galaxy. Each measurement reveals that interstellar space has its own magnetic weather patterns, invisible highways of force that guide particles across vast cosmic distances. The spacecraft continues to detect these magnetic anomalies, proving that the space between stars is far more structured and dynamic than anyone predicted. The cosmic ray avalanche. Crossing into interstellar space triggered an immediate and honestly shocking discovery. Voyager's cosmic ray detector recorded a sharp spike in high-energy particles accelerated to nearly light speed by distant supernovae and black holes. The increase wasn't gradual, it was abrupt, like stepping through an invisible barrier. This revelation exposed how effectively our sun's heliosphere shields Earth from the harsh radiation environment of interstellar space. We're living in a cosmic oasis, protected from particle bombardment that would be lethal to unshielded life. But the pattern isn't uniform. Voyager has detected systematic variations, suggesting natural radiation corridors, cosmic highways where particles preferentially flow. These measurements hint at larger galactic structures, possibly ancient scars left by stellar explosions that shaped our neighborhood millions of years ago. The spacecraft may be detecting pressure gradients that map onto invisible architecture spanning light years. Each cosmic ray measurement reveals more about the galactic environment, showing that we're not just measuring local conditions, but glimpsing the aftermath of cataclysmic events that continue to influence our cosmic neighborhood today.
Whispers in the void.
You know, the silence of space doesn't actually exist. Voyager's plasma wave instrument has completely shattered the old myth of cosmic emptiness by detecting these constant low-frequency oscillations that just permeate interstellar space. And these aren't just random fluctuations, no, they're structured signals, suggesting that the space between stars has its own unique acoustic signature. The instrument has even picked up multiple plasma density spikes, kind of like pressure waves moving through an invisible medium out there. Scientists think these could be shock fronts left behind by ancient supernovae that exploded thousands of years ago, still rippling through the interstellar medium today. So Voyager isn't just drifting through emptiness, it's flying through an invisible fog with its own distinct layers and properties. Some regions are hotter, others are denser, and together they create this complex three-dimensional structure that actually resembles weather patterns a lot more than the uniform void scientists once expected. This cosmic hum, it's really the background activity of our galaxy, a constant whisper from the space between stars. The plasma waves are revealing that interstellar space has its own dynamics, its own currents and temperatures, creating an environment that's far more active than anyone could have imagined.
Interstellar weather patterns.
Voyager 1 has actually passed through at least 2 distinct interstellar cloudlets since crossing the boundary, and this has revealed that the space between stars has structure, kind of like an ocean with currents and eddies. These aren't visible clouds though, they're regions where the plasma, dust, and gas density suddenly changes by factors of 2 or even 3 times. The spacecraft's instruments show evidence of these structured plasma ripples with clear boundaries, almost like atmospheric fronts out in space. NASA scientists now believe our sun is moving through the local interstellar cloud, and Voyager is helping to define its outer edges right now. This cloud exists inside the much larger local bubble, which is this enormous cavity created by ancient supernovae. These density shifts, they actually affect Earth's cosmic ray exposure over millennia. As our solar system drifts through different interstellar environments at 450,000 miles per hour, the radiation environment at Earth subtly changes, and that can potentially affect cloud formation and even mutation rates in living organisms. Voyager is showing us that interstellar space isn't just a straight path. It's really a gauntlet of invisible forces that create this complex, ever-changing cosmic landscape, complete with its own weather systems and boundaries.
Digital resurrection.
So, the 2023 communication crisis nearly ended humanity's only direct window into interstellar space. For months, Voyager 1 was transmitting incomprehensible data, its memory corrupted by cosmic ray bombardment. NASA engineers were suddenly facing one of their greatest challenges: remotely repairing a spacecraft that's actually older than most of their careers, and doing it with technology from the Carter administration no less. The solution took unprecedented ingenuity, rerouting decades-old code into backup memory areas while somehow maintaining all the critical functions across a 15 billion-mile gap. And every command took 22 hours to reach the spacecraft, so real-time troubleshooting was just impossible. The team basically performed remote surgery on a patient they couldn't see or touch. In April 2024, they finally had a breakthrough when basic telemetry resumed, and that was followed by the gradual revival of the scientific instruments. By June 2024, all 4 active science instruments were functioning again. This wasn't just an engineering triumph, it was humanity's lifeline to the only measurements we have from beyond our solar system's protective bubble. The rescue operation showed that even 1970s technology could be revived through innovative engineering, buying us precious additional years of interstellar data collection.
Mapping the invisible galaxy.
Voyager 1 is creating something, well, truly unprecedented, a navigational chart of interstellar space. With every data packet sent back, scientists are able to construct 3-dimensional models of the Milky Way's magnetic and radiation zones, using Voyager's measurements as crucial anchor points. This, honestly, represents the first real-scale cartography of our stellar neighborhood. It's a bit like having a weather satellite, but for the cosmos. The cosmic ray gradients, particle density readings, and magnetic field orientations are revealing natural shields and danger zones, and these could really determine whether humans can safely venture beyond our solar system. The radiation environment that Voyager measures is far more intense than what astronauts face in Earth orbit, which makes these maps absolutely crucial for any future interstellar missions. Some astrophysicists even believe the structures Voyager is mapping may influence star formation patterns across our galactic region. Quietly, the spacecraft is drawing the first blueprint of the space between stars, creating detailed models that get refined with every new measurement. This mapping project has, well, become the foundation for understanding how to navigate the void between stars, potentially guiding future spacecraft through the safest corridors of interstellar space.
The protected oasis.
Voyager's measurements have revealed a profound truth about Earth's place in the cosmos. Our solar system exists within a protective bubble that shields us from an environment far more hostile than anyone realized. The dramatic increase in cosmic radiation beyond the heliopause demonstrates how effectively the sun's magnetic field deflects dangerous particles that would otherwise bombard our planet. This discovery reframes Earth not just as our home, but as our shelter in a cosmic storm. The interstellar medium contains radiation levels that would pose serious threats to unprotected life, making our heliosphere a crucial barrier against galactic hazards. Voyager's data shows that this protection varies as our solar system moves through different interstellar environments over millions of years. The spacecraft's measurements of density variations and magnetic field changes suggest our cosmic neighborhood is far from uniform. We're traveling through a complex landscape of radiation zones, magnetic boundaries, and plasma clouds that create an ever-changing environment around our solar system. Understanding these variations helps explain long-term climate patterns and cosmic ray exposure cycles that may have influenced life's evolution on Earth.
The eternal journey.
Beyond its scientific mission, Voyager 1 carries humanity's most enduring message to the cosmos. The golden record attached to the spacecraft contains sounds, music, greetings in 55 languages, and 116 images representing Earth's diversity. This time capsule is engineered for extreme longevity, designed to survive over 1 billion years in the harsh environment of space. In approximately 40,000 years, Voyager 1 will make its closest approach to the star Gliese 445, passing within 1.6 light-years of this distant red dwarf. Long after Earth's continents have shifted beyond recognition, long after human civilization has evolved or disappeared, this record will endure. Voyager represents humanity's most lasting trace in the universe, an ambassador that will outlive our species. No other human object will leave the heliosphere for decades, making Voyager literally our longest-lasting monument. The spacecraft transforms from a scientific probe into something more profound, a message frozen in time, carrying the essence of who we were in 1977 across the galaxy for eons to come. This cosmic time capsule gives Voyager significance that transcends its scientific achievements, becoming humanity's first tentative step into eternity.
Redefining reality.
The space beyond our solar system isn't the featureless void astronomers once imagined. Voyager 1 has revealed a dynamic structured environment with weather patterns, magnetic topography, and radiation zones that shape our galaxy's invisible architecture. The transition from our solar bubble to interstellar space isn't clean. It's messy, complex, and honestly pretty fascinating. Magnetic fields don't align as expected, radiation environments change dramatically, and plasma waves suggest constant activity we never knew existed. Voyager's discoveries prove that interstellar space has layers, fronts, and boundaries, creating a textured cosmic landscape far more intricate than anyone predicted. The spacecraft continues operating on borrowed time, with NASA making difficult decisions about which instruments to shut down as power gradually fades. Early 2025 saw the cosmic ray detector powered down to extend the overall mission, but 3 science instruments continue transmitting their faint 23-watt signals across the cosmic void. Each day, Voyager 1 operates as a gift of knowledge from humanity's only direct sampling of the space between stars, rewriting textbooks with every transmission from the interstellar frontier. Voyager 1 reached the other side, and the reality is more extraordinary than fiction. The interstellar medium isn't empty. It's a structured, dynamic environment that challenges our understanding of cosmic architecture. From magnetic mysteries to plasma whispers, from radiation avalanches to cosmic weather patterns, Voyager continues revealing secrets that rewrite astronomy textbooks. This incredible journey proves that sometimes the most profound discoveries come from the simplest act of reaching beyond our boundaries. If you love real space exploration without the hype, smash that like button and subscribe to Stellar Tech for more mind-blowing cosmic discoveries. The universe is far stranger than we thought.